Why do people go bald?
Why are baboons' bums red?
What's a light year? Why do leaves go brown in the autumn? Why do monkeys like bananas? Why do some things glow in the dark? Why do animals not understand you? Why do my receipts fade after a year?
Don't know the answer? Ask the Naked Scientists.
Hello and welcome to this week's Ask the Naked Scientists with me, Sue Marchant, and Dave Ansell. Let's find out what's new in the world of science. Good evening, Dr. Dave.
Good evening, Sue. How are you?
I'm jolly well.
Me too. I found a nice little story. Now, if you're an astronaut, it's not a huge problem when you're near the Earth, if you're low Earth orbit, like the present space station. Mm-hmm. But if you venture out of that to the Moon or to Mars or anywhere outside just our own backyard, you've got a big problem. And the big problem is solar weather. Because if you have a storm on the sun, it can throw out huge they're called coronal mass ejections, huge piles of very high energy protons mostly, which fly out all the way to Earth. They can hit the Earth and they can cause problems on Earth even. They've tripped out electricity grids in Canada and things.
Ooh.
Actually, the reason why they're not a problem to us, the radiation is a problem to us, is they get trapped by the Earth's magnetic field and they kind of get funneled into the North and South Pole where they pile into the atmosphere and create the northern and southern lights. So the pretty lights you see up there are particles coming from the sun and smashing into the atmosphere, giving the atmosphere lots of energy and making it glow. But if you're on a spaceship, then there's nothing to stop them. They'll go straight through the ship, the computers, the astronauts. It can cause great havoc with computers.
Wow.
And it can give astronauts cancer, if not radiation sickness, if it's really powerful. In fact, the astronauts going to the Moon were quite lucky they didn't get hit by one, because in between the trips to the Moon, there were various events which would have basically killed them. Now, how do you stop it? At the moment, the only way is just build lots of armour. But something which some scientists at the Rutherford Appleton Laboratory down near Oxford, various people have done calculations to see whether you could use magnetic fields like the Earth does to see whether it would work. And the first calculations people did just thought that it had to be huge and it would never fit on a spaceship. So they thought, let's try it. So they got a little magnet. They put it in a machine which simulated these high-energy solar cosmic rays, put a magnet in the way, fired these high-energy plasma at it, and you got a little bubble in between. They're going to need to do a lot more work, but possibly in 20 years or so you'll be able to build a magnetic shield to protect astronauts from these big radiation events when travelling around the solar system.
Oh, I don't know, absolutely fascinating stuff. Anyway, we've got some questions lined up for Dr. Dave, and the first one comes in by email. This is from Bruce, and he says, hello, why do electronic displays and TVs use red, green and blue? That's a good question. I've often wondered that, because you look at the telly and think, why is that? Dave?
Okay, it's all to do with the way we perceive colour. Now, if you ever looked at a rainbow or you've played with a prism and you've seen rainbows projected on the wall, you can spread out white light into actually an infinite number of different colours. It's called a spectrum. The ones we can see goes from red through orange, yellow, green, blue, indigo, violet, colours of the rainbow. There's, in fact, an infinite number of different colours there. But our eyes aren't that sophisticated. Our eyes actually only have 3 different colour sensors. A colour sensor which is most sensitive around red, one which is most sensitive around green, and one which is most sensitive around blue. People who are red-green colourblind are missing one of these, so they've only got one which is sensitive around sort of red and green, one which is sensitive around blue, so they can't tell the difference between red colours and green colours, and they can get confused, and so traffic lights are a big problem. It's the reason why traffic lights are always the same, red, orange, green, because otherwise if you're colourblind and you can't tell the difference between red and green, then if they were in random orders, you'd be in trouble. You'd be going when you should be stopping. And I think train traffic lights aren't always the same way around, so you're not allowed to be colourblind and drive a train. And so the reason why a TV monitor is using red, green and blue is because those are the 3 sensors in your eyes, so you can fake every other different colour by just using a mixture of red, green and blue. Although it wouldn't be able to fake it for a bird, because birds have more different types of cones in their eyes, these colour sensors. Some of them have got at least 4, some of them have extra ones, so maybe 7, 8, 9 different colours. So you'd have to use a lot more different colours in your display to be able to make up all the colours to fool a bird. Because we've only got 3, then you can fool people just with using those 3 different wavelengths of light, 3 different colours of light to fake all the others.
All right, OK. Thank you very much, Dr. Dave. Now we have Les on the line. Good evening, Les.
Good evening.
What's your question for Dr. Dave?
Dr. Dave. Yeah, well, if there's a controlled expansion or whatever, so it didn't actually expand and burst, and a hot helium balloon was let go, or hydrogen balloon was let go into the atmosphere, would it ever stop travelling up? Assumably it would reach space.
Okay, it was basically, could you make a helium balloon get all the way up into space and keep on going?
Yeah, travel forever.
If the helium balloon was made out of just helium, then yes. In fact, the reason why there's very little helium in the atmosphere is that helium's so light it will just float upwards and upwards and upwards and upwards until it gets right to the surface of really high up in the atmosphere. Then it gets caught by the solar wind I was talking about earlier and blown off into into the solar system. But if you make a balloon, the problem is as soon as you make an envelope round it, then that makes it a bit heavier. And so it can't, because the reason why the helium can keep going up and up and up and up is it can keep expanding and expanding and expanding to an arbitrarily large size. And so it's always slightly less dense than the stuff around it. However, as soon as you've got an envelope around your balloon, you limit how far it can expand, and if either then it bursts or it's got enough strength to hold the helium in and then it can't expand anymore, at which point it can't expand, so it can't get any less dense. So as it goes up, eventually it gets to a point where the air is no more dense than it is, so it will just stop rising, it will just stay there. People have certainly designed helium balloons to go up to up to about 100,000 metres. 100 kilometres or so, which is probably on the edge of what's technically space, but to get any higher than that, there's so little air there that you just couldn't make your envelope light enough to be able to float on it.
Oh, okay, that's a question of the weight of the actual envelope of the balloon then.
Lovely, thank you very much, Les.
Yeah. Okay,
thank you. Okay, you take care, bye. Dr. Dave, good one from Andrew. He asks, is Professor Hawking's voice box connected to his brain? Good question.
I am fairly sure that it isn't. Last time I saw him in a lecture was quite a while ago, but the way his system worked then was, I think it still does, is he has a little switch in one of his hands because he's got some kind of neurodegenerative disease, and basically one of the few things he can actually do on command of his brain is gently squeeze a muscle in his hand. So someone puts a little switch in his hand, and then he can basically switch or not switch. And then he has a little computer program on a screen which sort of flashes the beginning of two possible words he might use. Then he clicks on the one he wants. And then it gives him the next letter on the word, and then he clicks on the one he wants, and the next one, and the next one. And so it's very, very slow. He took questions in the lecture I went to. And after about 10 minutes of frantic clicking, he got a sort of 10-word answer out. So it's horribly, horribly slow system. But yes, it's not directly connected to the brain. There is technology starting to get there whereby you could plug in directly into your brain. Although there's definitely been some examples with monkeys where they've done that sort of thing. They've got monkeys controlling robot arms. But they certainly haven't done it with him yet. I think he's probably quite a scary person to operate on. He's getting quite old now, and there's probably lots of other problems with this physically, because if you're not moving about a lot, it does very bad things to your internal organs. Yeah. So if I was a doctor, I'd be very suspicious of
very careful, as well.
He's probably not too keen either.
Yeah, he's just amazing, isn't he? He really is. All right, well, not particularly, I suppose is the answer to that one. Question from Eileen. She's called in to say, Dr. Dave, why do spiders not get caught in their own webs?
This is due to how they design the webs. The webs are made up of two different kinds of strands. A conventional web is sort of a star shape with a spiral going around it. The star shape, the stars, the threads going from the outside into the middle, are actually made out of a kind of silk which isn't sticky. So they're the ones the spider puts up first, and they form the structure of the web. And then the spider puts on a sticky spiral on top of this, going round and round and round. But the main thing is that the spider just stands on the threads which aren't sticky, the ones going from the outside into the middle. And if you stand on a non-sticky thread, you don't get stuck. It's quite simple, really.
Clever things, our spiders. Now, we have an email in from Jackie. Jackie asked Dave, hello to you both. Given the current thinking that we have all evolved as far as we can do, then what will happen next? Will we revert backwards? Jackie, nice one. Thanks for your email. Dave.
We haven't really evolved as far as we can do by any means. Evolution is a kind of very, very simple idea. Basically, all it says is that if you've got a whole population of slightly different creatures in one generation, and then some of them survive better than others and have more children than the others, then the next generation is going to be more like the creatures who had the most children and the most of the children who survived, because they're the creatures which are alive in the next generation. You keep on going for hundreds and thousands of generations, and then maybe if the creatures are faster at running, then and that's a good way to survive, then slowly the creatures which survive and their children and their children and their children will be the ones who can run fast. Or if being intelligent is a good way to survive, then slowly the more intelligent ones will survive and survive and survive and survive. We certainly haven't evolved as far as we can do. All evolution is just survival. So basically, if we keep on going and surviving, then that's a good thing as far as evolution is concerned. So basically, the question is, if we're going to change, how is the population of humans going to change? In which case, probably the best question to ask is, at the moment, because especially in the Western society, everyone is surviving. Very few people are dying in childhood or dying before they age to reproduce. The answer to that question is basically whoever's in the society is having the most children, the next generation is going to be more like them. So slowly the population is going to evolve to be like the people having more children. And I'll probably let people come to their own conclusion as to who they are and what that means for society in the long run.
Can be scary in some places, can't it?
Yeah, I mean, if technology keeps advancing at the rate we're going at the moment, probably designer babies will come in the next few thousand years, and we'll start actually engineering people how we want to do.
That's awful, isn't it?
Which is it's kind of scary in some ways.
Very scary.
In other ways, I think it's inevitable.
We're already starting to engineer people, though, aren't we? By giving ourselves new bits and pieces and stem cells and all those other bits and pieces.
If nothing else, just wearing glasses for the last 500 years has meant that people with bad eyesight have survived and done well and had lots of children. So there are probably more people with bad eyesight than there would be if we hadn't had glasses. Yeah. And if you keep on going with those sort of things, you're going to be spending so much effort kind of correcting all the defects that it would be a lot easier to engineer them out sort of genetically. It's probably over thousands of years, and it's not anything we've got to worry about in the next couple of generations. Not something to worry about now, though.
Fits in with the music, doesn't it? It really does. Good evening, Terry. What's your question?
Good evening, yes. I'd like to know if anybody has successfully produced a flying saucer. I'm into model engineering myself. Yeah. And I've never seen a plan for one.
Good question.
And I can't see why it can't be done.
Define flying saucer, because certainly people have made saucer-shaped things fly. You can make, I think the Germans made some pretty circular things which act like a wing. They've got the right curvature for a wing. And if you put a big engine on the front, then they would fly. People have built circular things with big fans in the middle, basically work like helicopters with stuff around the outside, and they can fly. People are quite keen on using them for unmanned aerial vehicles.
Well, I don't see why an outside ring can't be built around a circular passenger area. Dependent upon the aerofoils you put on them, it will get the right amount of lift, and you can have a vertical opposition unit going against it, if you know what I mean. So that you should be able to fly as just a complete disc.
So, I mean, are you talking about having something spinning around the outside of your flying saucer?
Yes.
So it's a bit like a sort of helicopter, but with the helicopter blades on the outside of a circular thing?
Well, it's not helicopter blades. It would just be jet propulsion with airfoils on.
If you've got enough power, you can make almost anything fly. The real question is how efficient it is, because if you're going to shift people around the world a long way in an aircraft, you're really, especially it's getting more and more important, is how much fuel you're burning. Some of the reason why people haven't explored really interesting different shapes of planes is that they've worked out one which works now, and redesigning and building a different type of plane is going to cost a lot of money in development. But some of it is just the designs of planes we've got at the moment work pretty well. They're probably not the optimum ones, but they're pretty good. I have a feeling that a perfectly circular plane probably isn't quite as aerodynamic as a conventional plane, and so it would burn slightly more fuel to use, at which point it'll cost more money and be worse for the environment, so your tickets are going to cost more.
Thank you.
All right, Terry, thank you very much indeed.
Thank you.
Thank you. Bye-bye.
Bye.
Bye. If you're enjoying Ask the Naked Scientist, then you might like to check out The Naked Scientist, our regular roundup of the world's best science. Each week we take a look at the latest science news, talk to top researchers working at the coalface of discovery, and also get our hands dirty with a science experiment that you can join in with too. So make it a date and prepare to strip down science on the web at nakedscientist.com/podcast. Talking of planets, Terry in Sawston says, why are planets and stars all spherical, as they are meant to be formed by matter colliding? Why are they not haphazard shapes? That's a good one.
Well, if you look at very small objects, things like asteroids or things called Kuiper belt objects, things like Pluto, very small things which don't have a lot of mass, they are haphazard shapes. They're sort of donut-shaped or kind of flattened asteroids or ones which look like dumbbells. It's all sorts of strange shapes, and comets can be quite strange shapes. But as soon as you start getting very massive and very big, then the object's own gravity starts to play and become important. And gravity, basically, everything with mass is attracted to everything else with mass. So I'm attracted to you, the walls, the chairs, everything, very, very slightly, but immensely tiny forces. The only thing which is big enough to create a force large enough for you to actually feel is the Earth, because this is huge underneath us. If you imagine an object, everything inside this proto-planet is trying to get the gravity is pulling it to be as close to everything else as possible. And the shape which is best for this is a sphere. Because if you imagine pulling a sphere into two halves, and the two halves can into two blobs, and the two blobs can move together and get close to each other. If you pull it into a rod shape, then the rod can get close to each other by moving back towards the sphere. So it's basically just because gravity is trying to make everything as close to everything else as possible, and the shape which is best for that is a sphere.
All right, thank you very much, Dr. Dave. So from spaceships then to trains, John in Peterborough has called in. John asks you, Dave, we often hear about overcrowded trains. His question is there a limit to how many trains can run on a track at any one time?
Yes, there certainly is. There's various different limits. There's a fundamental one which is to do with if you've got a train, a whole row of trains going through a whole series of stations on a track, as they speed up, because they're not all going to reach the stations at the same time, you're always going to have some of them stopped at the station. They're going to speed up and slow down and speed up and slow down. And as they speed up, they're going to get further away from the train behind it. And as they slow down, then the other train's going to catch up with them. And so the most trains you get on the track would be that when just as one train is leaving a station, another one is pulling into it behind. Then the next one leaves as soon as the next one's pulling in behind. And the limiting factor will be wherever you've got the two stations are closest together, and various other, and if you've got any hills in there, that makes a difference, and whatever. Practically, the limits which you tend to reach long before that are to do with how they design the signalling, because the people who design railway systems are completely paranoid about safety. I've got a friend who works in it, and they really do just engineer everything to be fail-safe. And they're completely psycho about this. And so basically the fundamental way that most signalling works is you have a block, a length of track, and you can only have one train inside this block. And you can't have a train in that block or the block behind it, so because the train in that block could be right at the beginning of the block, so you've got to have space behind the train.
Sure.
Just so the train behind it doesn't see a red light and so suddenly crash into the one immediately before it. So basically every train has to have at least two blocks. And so the length of these blocks is very important. There was a big problem in the 80s when they redid the underground signalling, because they lengthened all the blocks, because it was cheaper, because it involved less lights and less wires and everything. But that meant that because each block is longer, then the two blocks between each train and two blocks took up more space, so you can get as many trains on the track. There are more sophisticated systems where you use lots and lots of short blocks. And then you're working out all the time the distance which the train behind, if the train at the front slammed on its brakes as hard as it possibly could, or was suddenly stopped, then the train behind it has always got enough space to brake before it hits it. I mean, it's basically all to do with designing it, so the limit is to do with two trains not hitting each other, and it depends on the signalling, exactly what that limit is.
Now, Mark in Suffolk, he's called in and he says, looking at the theory of evolution, if women give artificial birth on a regular basis, would it ultimately, through evolution, make natural birth redundant and in turn affect the birth process? Ooh, another scary one. Thank you, Mark.
I mean, fundamentally, if somehow women are giving birth artificially, so if all the organs inside them which are needed to give birth naturally, if there's a woman where that doesn't work, but if you can give birth artificially, then that's fine. Basically, normally, if someone is infertile, it gets evolved out of the system very quickly because they don't have any children, and so the genes which lead to that infertility don't carry on. So infertility is always being weeded out very quickly out of the gene pool. But if you don't have this process and women can breed without having a working reproductive system, because they've got some kind of artificial system, then more and more people won't have a working reproductive system because it's not being weeded out all the time. And so slowly more and more of the population would be naturally infertile. But it doesn't matter because you've got this artificial system there. In the same way as if people can see using glasses, more and more of the population can survive perfectly happily when they're short-sighted. So you'll evolve more and more people who are short-sighted.
So you'll be assimilated then, a bit like the Borg. Now then, Dave, Tesco Tom says, why does soap in your eyes irritate you so much, and why does it take so long to get rid of it? Yeah, it's absolutely painful. Why is that?
Okay, again, it's not my specific area. Chris would be better, would give you a more definitive answer. But I think a lot of the reason is that your cornea, the surface of your cornea, has got an incredibly large number of pain receptors on it. Basically, if you've ever touched your eye, or I can't understand how people can put in contact lenses, it strikes me. Horrible.
Me too.
Because your eyes are so important to you and they're so delicate, we've evolved a huge number of pain sensors on the surface of your eye, so as if you do anything to it, you know about it and you don't do it again. So you've got a huge number of pain receptors on there. The way soap works is that basically all living cells are fundamentally sort of bags of water covered in a fatty layer on the outside. The cell membrane is basically a fatty layer. Soap dissolves fat, so it will break open this fatty layer, spilling the contents of the cell out and killing it. That's the reason why it's good at killing bugs, because it just dissolves away the membrane on the outside. The cells explode, they die. It doesn't do you a lot of harm on your hands and not most of your skin, because the surface of your skin is already dead. So there's nothing there to explode, and so it doesn't hurt at all on your hands. If soap gets on any kind of living tissues, it's quite unpleasant. When it gets inside your mouth, it's more of a problem. I mean, definitely living tissues it will do damage to, and your cornea, I think, is actually alive, so it will start destroying the cells in your eyes.
Sure.
Why does it take so long to get rid of? Probably just because it's quite difficult to get rid of soap. Very small amount of soap is quite painful. So you've just got to rinse it out with a huge amount of tears, and there's a limit to how fast you can produce the tears.
All right, thank you very much, Dr. Dave. Now then, John has sent a text in. He says, why can't the human eye see infrared, but if you video a camera or remote control, it shows up as a white light?
Okay, the way your eye sees light and the way an infrared video camera sees it are slightly different. Your eye has a series of different pigments which are sensitive to light, and they're sensitive to a range of frequencies of light. The ones in your red sensors are sensitive to red light, green sensors green, blue sensors blue, and colours of light around that. So both red and green will be sensitive to yellow light. And just none of these pigments are sensitive to near-infrared light, which your remote control transmits on. Your camera has a little sensor which will detect pretty much any colour of light, which is sort of bluer than something in a sort of middle infrared light. And then you have to put things in front of it to stop light. So you put a little filter on the top of some of these sensors to let only blue light through, some let red light through, and some let green light through. And you can build up a colour picture by which sensors fire off when you shine different colours of light on them. Why can't we see a near-infrared light? I guess there's basically just been no particular advantage to doing so. Some animals certainly can. I think definitely some insects can see in the near-infrared, and I think some birds start to be able to see down there. I guess for some reason it's been advantageous for them over millions of years, so any animals which develop this ability will survive longer and become more common.
Tony has called in. He says, is the moon still bombarded by asteroids and meteors as it is shown by the craters on the moon, or are these hits visible from Earth? Does that make sense to you?
Yes.
Okay, all right, good. I'm pleased about that. Dr. Dave, the moon.
Okay, the moon has had a very violent history. It's been hit by all sorts of things going very fast, because anything moving around the solar system, the odds are it's going to be going very fast compared to anything else. And so when they hit the huge amount of energy and they smash into the moon, blowing huge great craters. The really big craters mostly date from right near the beginning of the universe, beginning of the solar system, so sort of 4.5 billion years ago. In fact, you can quite often date planets and moons by how heavily they've been bombarded. If they've been very heavily bombarded, then they must have been around. Their surface must be very, very old. The other bits of the moon, you can see sort of lava flows on them, which are a bit younger, especially inside the middle of the really big craters. And those are much less heavily bombarded. Is it still being bombarded? Yes, it is. In fact, I think some amateur astronomers discovered this quite recently in the last few years, that they've basically been having their own telescopes. You get some quite serious amateurs. And the thing is about amateurs is they've got lots and lots of spare time. And whereas with a professional astronomer, essentially can't really spend his time sitting there watching the moon day after day after day after day, because he won't get paid anymore because he's not discovering anything interesting enough. The amateurs, there's no reason why not. So there's various things which they discover. One of them is supernovae, which are exploding stars. In fact, one of my housemates has written some software for them in order to help them do this. And there's one guy somewhere in Britain, I can't remember where he lives, who has like 3 or 4 big telescopes in his garden, and every night he goes out looking for exploding stars, and he found sort of 3 or 4 this summer which no one else found. He gets his name on them. The amateurs who are watching the moon, they're just watching the moon, and occasionally you see little flashes of light if you look at the side of the moon in shadow. And these are little asteroids piling into the moon, release lots of energy. You get a cloud of sort of glowing gas, sort of vaporized rock from the moon. He forms a little tiny crater. The craters, I don't think anyone's actually found a crater from it. But you see little things with sort of the power of several tons of dynamite going off occasionally, not that often, but occasionally all over the moon. And it was definitely, and you get lots of micrometeorites, little tiny fragments of dust hitting it all the time, which is again a danger for astronauts wandering around on there. But yeah, it is still getting bombarded, but much less heavily than it was when it was older.
I can just imagine what it's like, with your housemates, the scientists. It would make a brilliant sitcom, wouldn't it? All right, one last question for Dr. Dave has to go. Linda in Shelford, I don't know whether this is your area, but she says, I've always understood that if 2 blue-eyed people have a child, it could not have brown eyes. Is this true? Ooh, how's your biology?
Yes, I think it is pretty much true, but nature's always slightly odd, and sometimes you can never quite tell, but it's pretty much true. The big gene which controls what colour eyes you've got, there's 2 major ones. There's a blue gene and there's a brown gene. Everyone's got 2 of these genes. If you've got 2 blue genes and you've got blue eyes, if you've got 2 brown genes, you've got brown eyes. But if you've got 1 blue eye and 1 blue gene and 1 brown gene, because the brown gene is what's called dominant and kind of overpowers the blue one, so if you've got 1 of each, then you've also got brown eyes. So 2 people with blue eyes haven't got any of the brown genes, so they have to have blue-eyed children. Right. If you've got 2 people with brown eyes, they might both have 2 brown genes, in which case they have to have brown-eyed children. But if they've both got 1 blue and 1 brown-eyed gene, most of their children with brown eyes, but you could inherit blue-eyed gene from both your parents, even though both your parents have brown eyes, and then you could have blue eyes.
That's it for this week. Our doctors will be back with me next week for more Ask the Naked Scientist. But don't forget, you can also catch them on the Naked Scientist podcast, which you can find on the Naked Scientist website, www.nakedscientist.com.
The Naked Scientists are sponsored by the Wellcome Trust, the EPSRC and UK Fast. For more information, look us up online at nakedscientists.com.